Denominator is 0, right? What about the numerator? 0 also, right? So you have 1 over square root of x minus 1 over square root of x. Anything minus itself is 0. So that's not a good thing. It's a great thing. So that means we get to use some algebra. But what would your instinct tell you to do here? I mean, common denominator, but then also square roots should be making you think conjugate. And it turns out in this problem, they're both correct, but you have to do them in the right order. So the correct order here is first a common denominator. So let me see, what would my common denominator need? I would need what on the first fraction? I'm missing a square root x, right? Top and bottom. What am I missing on the second fraction? Square root of x plus h. Everyone realizes that all I'm doing is multiplying each of those fractions by 1. So I'm not changing the problem. I'm just being very clever. Now you want to get to the point where you can just write the next line as one, like the fraction already put together. So what would it be already put together? Square root of x, did you say minus? It's minus because there's a minus sign between them. So minus what? Plus h, and then over the square root of x times the square root of x plus h. That's our common denominator. And then all of that over h, which will turn out to be an h over 1. But not yet. I'll do that later, okay? All right, so we have that. Now, if you check this yourself right now, and just tried to let h go to 0 right now, you'd still get 0 over 0. Because nothing has canceled yet. You've got to get the cancellation before you can actually take this limit somewhere. So now what? Now the conjugate. So I'm going to multiply the conjugate. What would the conjugate be? Square root of x plus square root of x. Where do I put it? I think most of you would probably say this, but where do I put the other part of it? Right underneath it. Okay, right there. And that's multiplication there, isn't it? So I've multiplied by 1. And now I have the pleasure of expanding that out. Now the numerator, by design, I mean, the reason we come in with the conjugate is because the numerator should clean up. It should turn out to be something really nice. The denominator, that bottom part, the denominator it's going to multiply with the blue over there, right? This and this, I'm just going to put them next to each other in parentheses. That's all I'm going to do. I'm not going to try and multiply those out. And that's kind of like the rule of thumb you should follow with this. Multiply out the numerator, but leave that denominator alone. So what would you get if you multiplied out that numerator? So this would multiply the roots together. You just get x, right? Because the roots go away. And then what can you automatically say is going to happen to the middle terms? They're going to disappear. And that's why you don't need to show it, okay? I'm going to write it just because, again, I'm trying to help you by showing as much as I can. But you don't have to. If you know they're going to cancel, you don't need to show me this. Those are my middle terms. Now, I see so many students make a mistake on this part. What's the last term? Positive or negative? Minus x plus h. Is that correct like that? No. What's wrong? I need a parentheses around the x plus h. Good. Now the reason why is because root x plus h times root x plus h is x plus h. But because it's a negative and a positive, it's minus. That minus must distribute to both of those terms. So it has to be in parentheses. Does anybody want to volunteer to make that mistake on the test for me? Who wants to volunteer? So no one's going to do that? Okay. Here's my denominator. Times, now in parentheses, why am I putting this in parentheses here? I'm doing this multiplication, this right here times this. So there's the first part right there. Why did I put this in parentheses? Yeah, because it's two terms. They're separated by addition. So I have to put them in parentheses so that when I multiply, it would actually go to each one. Right? I don't need these in parentheses. Why? It's multiplication. These are these little subtleties of calculus that I'm trying to get you to be aware of, all the algebra involved here. Now, all of this is supposed to be divided by what? H. And let me start killing some stuff off here. I can kill off those middle terms. And over here above this one in red, I'm going to actually distribute. It was minus x minus h, right? So that will allow me to kill off the x in the front and the x in the back. So let me rewrite it now. Equals limit h goes to 0. What's the only thing left in the numerator? Negative h. All over this monster denominator. All over what? H, which I'm not going to write as h. I'm going to write it as 1 over h out here. So I'm going to take that h that was down there and I'm going to flip it up. Is that all right? And do you see the h's, how they're going to cancel here? H there are going to be gone. Yeah, that means that we're going to have a negative 1 on top. Okay? And I'm one step away from the end of this. I have a negative 1 on top. Then I've got this horrific thing. Even my computer doesn't want to do this problem anymore. It won't let me write. Is that okay? Now let h go to 0. So when h goes to 0, this is gone, and this is gone. Just that piece, right? Just those two pieces are gone. And I'm no longer going to write the limit, right? Because I've let h go away. So on the bottom, I have a what? Square root x. What's that second one become right here? Square root x again. And then here's my parentheses. Square root x plus what? Square root of x. Yeah, I was just making sure everyone understood. So the first part of that becomes just an x. And what about what's in the parentheses? 2 square roots of x because you're adding, not multiplying. And this becomes negative 1 over 2x to the 3 halves. What the hell happened there? Well, that's the same as 2 root x times x. And that's the same as 2 times x to the 1/2 times x to the first. And that's 2x to the 1/2 plus 1, because when you multiply two things that have the same base, you add the exponents. And 1/2 plus 1 is 3/2. And that's the way we'll write it in this class. Now, on a test, if you got to this, I mean, you get a lot of the credit here. But this would, I'd smile when I see that. Where that, I'd be like, okay. Woo. All right, we're through the first set of problems from this section. We've got a few more to look at. So I would like to point you to the notes again. If you could look at 1.4.6. And I think I'll start a new page here. Ah, 1.4.6. There are two limits that every Calculus 1 student needs to know. The first one, the limit as x approaches 0 of sine x over x, that equals 1. Now, let's just check this ourselves. If you plug 0 in, what is sine of 0? 0 over, now plug in 0 on the bottom, you get 0 over 0, right? So let's say I had not told you the answer was 1 here. You would get 0 over 0, wouldn't you? And then you'd say, I need to do some algebra or some trick. There is no algebra and there is no trick that you're going to be able to do to this. In fact, to prove that that is 1 without looking at the graph requires a pretty elegant, pretty beautiful proof. And it's in the book if you're interested in looking at it. The book has the proof. It starts on page 42. And if you really want to understand that proof and you want to come to my office and sit down, I'll show it to you. It's not impossible to understand, but I think it's a little much to read. But you can go for it yourself, all right? We are going to take this on faith in this class. We're just going to say, okay, I believe it's 1. Now, if we look at the graph, I don't think I have the graph. Well, actually, I think it was in your CDF lecture notes, to tell you the truth. Yes? Did someone say yes? What section is this? 1.4? Oh, that thing's annoying. Come on. Two very important limits. Oh, I thought I had the graph in here. Oh well. I don't have the graph. How satisfied are y'all? I don't want to overkill here. Let me plot it real quick. Plot. What am I doing? Sine x over x on the interval -3, 3. There's the graph. That's the graph of sine x over x. So I hope you are convinced just by looking at this graph that as we approach 0, right, as x goes to 0, from the left it's headed towards 1, from the right it's headed towards 1. But what's really sitting there? A hole, right? So we'll just take it on faith from the graph that that's it, all right? Now, I don't have this in my notes, so I want to also show you something else. The limit as x approaches 0 of x